specifically struggled with?
Yes,
Which one?
all of them.
All of them?
Every time.
Okay,
That
well,
is
let's,
literally the opposite of what he just asked.
let's just start with 3 then, because it's the one I can best see.
Okay.
So what form of equation is this in?
If you go back on the clicker, you can see the other two more
I
easily.
don't have it right now.
Oh, wait, what? Oh, because it's, gotcha.
Yeah, it's fine, we can
I'll
start
fix
with
it
3
in a
then.
second.
What form of equation is this in?
Point slope,
What'd you say?
point slope.
Is it point slope?
Wait, no, it's slope intercept.
Slope intercept, so y equals mx plus b. Alright, our m is our slope, our b is our y-intercept. So what is our slope here? It has it written up there, by the way.
Oh, -4.
-2 plus 4.
I can't see it before.
So
2.
if our equation, it's also on your sheet, but our equation is y equals negative x plus 4. So what would your slope be in this equation?
Negative x.
Negative x or -1. -1 would be our slope. Alright, now what's our y-intercept?
4.
4. Okay, so let's start with, go to your graph, and first thing you want to start with is your y-intercept. That kind of threw me off. So you're good. It moved backwards on it.
Yeah.
So
Broke it, Mr. Kenny.
start by plotting your y-intercept. Now, if we have a slope of -1, what's our rise, what's our run?
1/1.
Is it 1 divided by
Negative
1?
1, 1.
Negative 1 divided by 1.
Okay, so do I go down 1, up 1, left 1, right 1? What do we do? From this point. What is that?
Up 1
Up 1?
to right 1.
Right there?
Up
Yeah.
1, left 1.
So it needs to be negative, so either up 1, left 1, or down 1, right 1. We gotta have the negative direction for one of those. It can either be your rise or your run, but it's gotta be -1. So
what I did was 2 positives.
once you plot all those points, then all you do is just take a straight edge and you draw a line through them. So if that's how we did that one, let's look at 2. I'm guessing 2 gave us some problems based on looking at this.
That's my favorite number.
What do we think the slope of 2 is?
Negative half
-1/2.
plus
Alright,
8.
what is our y-intercept?
8.
Okay, so what should be our first step?
Go down half a box
From where?
from the middle.
From your y-intercept.
From your y-intercept, right? So you plot the y-intercept at 8. And now, what's our rise, what's our run?
Down to the right.
Down how many?
Half.
Down a half?
Yeah.
Is that it?
Then over half. To the right.
That's what that would be.
Mm-hmm.
See, that didn't work.
That'll work. So
Crap.
remember,
Or how's it gonna work?
we have our rise,
Oh, you go down 1
Divided by our
over
run.
2.
which is in this situation, -1.
Yeah,
divided
that
by
sounds
2.
right.
Down 1
Okay.
over 2.
Down 1 and then over. When you say over,
To the right twice, Mr.
To
Lipple.
the
Thank you.
right or
Right
to the
twice.
left, it's your choosing.
I remember your name by thinking of fish.
okay. So, once again, once you put multiple points in that line, all you do is just take a straight edge, draw through the line. Now, I do want to note that now that we're learning how to create these lines, how do we answer these questions down here where we're asked, is the point a solution? How do we answer that question? What do we look for? Alan, what do you think? If I asked, let's just look at number 2. How do we know whether the point 0.07 is a solution?
If it, never mind.
Hey, Alan.
I'm not sure. Alright, so just pay attention. Caroline, what do you think?
I don't know.
sure?
Actually, no. If it's like a point in the line, like along the thingy,
Along what?
the line.
If it's a point on the line, it's a solution, right? Because when we have a line, every point is a solution to that equation, right? So 0.7 is right here. So would that be a solution?
Mm-mm.
No.
No? Now, if you end up in a situation where you're not 100% sure, you can substitute that point into your equation and solve from there to see if it works. So here, what Mr. Kenny did is he substituted 7 in for y and 0 in for x, and you got 7 was equal to 8, which isn't true, right? 7 can never equal 8, so we know it's not a solution to that equation.
Really quick question, because I don't remember how much we talked about this in this class, but in mathematics, a lot of people try to talk about solutions in a lot of different ways. There's actually only one thing that a solution means. Does anyone know what we mean mathematically when we say a solution?
Equal.
Not quite.
Equality.
So I think you're meaning kind of like an answer, like if x equals 2, a lot of times we're looking at stuff like that to solve for an answer or to find what something equals, but it's not quite a solution.
Equilateral.
Can you write x is less than 7 up on the board?
Yeah. X is less than 7.
Caroline, would an x value of 8 be a solution to that inequality?
Can you repeat that? What did you just say?
Would the x value of 8 be a solution to that inequality?
No. I mean,
Good job,
Like to
Caroline.
the
Huh?
graph?
He's
Like
talking-
to
he's
the-
talking-
No, x is less than 7.
What I just read
The
right here.
inequality.
that's the wrong answer anyway.
Well, wouldn't it be? No,
Why not?
because, mhm. I don't know what you mean, because it's
So-
not even a point on, I don't.
So let's
Okay.
disregard these numbers right here. We're just looking at x is less than
Okay.
7.
Less
If-
than 7.
Is the x value of 8 a solution to that inequality? If we substituted 8, would it be
I don't know what
Mm-mm.
answer is.
No, say it's not. So I just said a very key word.
8 is not less than 7. Or it
Okay,
can
so
never
it
be less
is-
than 7.
Not
Okay.
true. That word's important. So a solution, we're talking about a solution, it is something that makes it true. So for this equation, all of these points, it's an infinite amount of points, but all those points make the equation true. So here when we substituted a point that wasn't a solution, what happened? We got 7 is equal to 8, which is not true. You see what I'm saying? So when we talk about solution, it is something, it makes it true. We're talking about equations, inequalities, there's plenty of other things, but for right now, we're just looking at that.
So
That makes
Brayden,
sense?
if anyone ever asks you mathematically what a solution is, what are you gonna respond with?
Like, what do you mean? Like,
What did Mr. Living just talk about?
What's a solution?
a solution is like an answer?
I don't think that's what Mr. Living just said. See, we need to pay attention to the language. We zone out and think that we know answers when we don't, and this is important.
Gavin's
A solution is a truth. Is it true or not? That's not true because 8 is not less than 7. So I listened. Thank you.
Close on the language.
Close.
Yeah, very close.
But close doesn't count in this, Mr. Kenny.
It's close. We're gonna keep developing it, but
We keep talking about
keep
that.
focusing on the solution as something with truth. It is not the answer, because your answer can be wrong. The solution is never wrong.
Dang it, I'm a failure.
How did we do on the other ones, on the other two? Do we need to go
Actually,
through
this, I mean, this I guess is good. Literally notice how this is asking, is the given value a solution? With number 16, yes, it is. Here, let me make it a little bit bigger, I guess.
Okay, good fellow.
Which I did not, I guess, test it the best way to illustrate this idea. Linnea, what's 4 times negative 3? You don't have to go set it. I would use a calculator.
Negative 12. Is that-
Okay, and then negative 12 plus 3.
don't you need it? Negative 9.
So McKay,
Mhm.
we substituted negative 3 in. It gave us negative 9. So is negative 3 a solution?
Yeah,
Why?
because you can multiply something to negative 3 to equal 9. I don't know. I'm looking at that, I'm still confused about it.
So what we did here is we have 4a plus 3 equals negative 9. And when we substitute negative 3, that it got us negative 12 plus 3 equals negative 9. And when we put that in a calculator, we got negative 9. Is negative 9 equal to negative 9? Is
Yeah,
that true?
True.
that is true on most occasions.
On all occasions.
I haven't,
So-
I said most because I haven't met one yet.
So that's why for a for negative 3, it is a solution because it makes the equation what? True. That's, we're gonna continue to hammer on that. So, just taking a guess here, we said yes for x equals 4/3, so what do you think that means for when x is 4/3?
4/3 equals 4/3.
I think I'm gonna have to go with that answer too.
So, I mean, 4/3 does equal 4/3, but why do we think that the answer to that was yes, based on what we've been saying this whole time?
It's true.
What is true?
If 4/3 equals 4/3.
So that is true, but that's not what we're looking at. We're not looking at 4/3 equals 4/3. So what do you think happens when we substitute 4/3 into this equation?
The equation will equal 3 seconds.
Yes, the equation will equal 3/2, or it'll make the equation true. That's what we're gonna continue to work on that, because I do wanna get into the task today. But when we're looking at solutions, it's about making the equation true, or making the inequality true. So if I tell you that 3 is a solution, 3 would make that equation true, or whatever we're looking at.
Oh.
We'll continue to work on that.
That's pretty nice, you don't get it.
So we're gonna go back into 4.1, which we were working on Friday, and then keep working on, did we all finish, I know a lot of people were in and out on Friday, did we all finish number 1?
Number 1 continues to repeat.
Yes.
Yeah, basically.
You left early, didn't you? You can go and switch back to that group again. You'll finish number 1, right? Okay, so, while you were here, did you finish number 1? Okay. So let's look at, let's kind of familiarize ourselves. So first look at the objectives. So, McKay, what was our first objective from Friday?
First objective. I can write an equation that represents a real-world scenario.
You're not McKay.
Oh, I didn't hear you say McKay.
I'll read number 2.
Go for it.
I can solve equations in one variable through using the properties of equality in the best order for the equation.
Let's test our memory. What did we say the properties of equality were? Y'all are so much more dead today than y'all are on Friday.
I'm lively.
I don't remember Friday.
I'm like a fresh shrimp on my foot.
So we'll continue to talk about this, but the properties of equality is when we do something to one side of the equation, what do we do to the
You
other
gotta
side?
do it to the other side
Do it to
too.
the other side. We do the same thing. So we started using that on number 1. So
Sorry, there you go.
we were looking at number 1. We were creating an equation for this situation. I think we, and this is one thing I want to talk about before we jumped into number 2. I think I saw 2 different equations. So, Gavin and McKay, what equation did y'all get for number 1?
Oh. 4C equals 60, C equals 15. I think.
4C equals 60. That was your whole equation?
Was that ours,
That
McKay?
was the whole
No,
equation.
parentheses,
So 4C, right?
in the parentheses, minus 24, close the parentheses, division sign, 3 equals 12.
Okay. And then I think Alan and Lene, I think y'all's group had a slightly different equation than that. What did y'all have for number 1?
We had 4x equals 24 plus 12 times 3.
It was 24 times what?
24 plus 12 times 3.
So what's different about these 2 equations?
Nothing,
Nothing. What do you mean?
just the
I
way
see
they're
some differences.
presented.
What do you think? Come on, guys. What are the differences between these equations?
They're equal differently.
They equal differently, okay, so this one's equal to 12, this one's equal to 24 plus 12 times 3.
One's multiplication, one's division.
One's multiplication, one's division. Do we think that both of these are correct?
Yes,
Why?
because you let them go on the board.
Could be wrong.
They put wrong solution up there before, but they both equal out the correct answer.
They both give you the correct answer. So what did y'all both get? What was the answer?
15 for Crete.
15. So
Oh,
c
yeah.
equals 15 or x equals 15, whichever variable we decide to use. Y'all both got 15, right?
Mm-hmm.
So if these two equations look different, but they get you the same solution, what is the word for that? When they look different, but they're
Equal out the rule.
Quite.
Equality.
so not equal.
Inequality.
There, it's something to do with the word equal.
Well, it's
Intervals.
No.
dang it.
Equivalent.
Equivalent. Thank you. These are equivalent equations.
Yeah. Give daddy a fist bump.
They are equivalent equations. So both groups went through the steps of this problem and assigned mathematically, how they felt the steps were going, but ended up with different looking equations, but they get you to the same point. They get you to the same solution because they are equivalent. So what I want to do is I want to go ahead and, because I liked where we got to on this problem on Friday, so I want to go ahead and jump into number 2. And that's what we're going to work on today. We're going to work on number 2 and number 3, hopefully if we get there. But let's go ahead. I'm going to give y'all, where's the clicker? There it is. I'm going to give y'all in your groups. I think one group at least started on 2. I don't know if everyone did, but I want y'all to just read through. So for number 2, you have all these